In this video, we will be discussing the process ITRC recommends for evaluating petroleum vapor intrusion in cases where screening distances could either not be applied or they were insufficient to screen a building out. This video will present the steps involved in carrying out a site investigation that eventually leads to a decision on whether vapor control or site management is necessary. Additional information on site characterization strategies can be heard in a complementary video on PVI site investigation called Bottoms Up to the Characterization of Petroleum Vapor Intrusion. The next step following site screening, or steps 1 through 3 in ITRC's 2014 Petroleum Vapor Intrusion Guidance, is to compare existing site-specific chemical concentration data to risk-based screening levels defined by the local regulatory agency. You can think of this step as a secondary screening step that simply requires additional data collection, which is often the measurement of subsurface vapor and/or indoor air concentration for key chemicals of concern. Regulatory agencies commonly recommend the vapor intrusion screening levels defined by US EPA, which can be determined using their online calculator. Choosing what and where to sample largely depends on the location of the vapor source relative to the building foundation. For vapor sources that are not in contact with a building foundation, subsurface vapor sampling is generally preferred over indoor air or groundwater sampling because A, there's a high likelihood of encountering background sources in indoor air or exceeding risk-based screening levels in groundwater for key chemicals of concern. And B, subsurface vapor samples are going to reflect the effects of biodegradation in the vadozone. The latter can be significant. For example, a published evaluation of US EPA's petroleum vapor intrusion database showed that concentrations of benzene and soil gas were biodegraded below risk-based screening levels in over 60% of the vapor samples collected within just a foot of an LNAPL source. However, if the contaminant source is in close contact with a building, or there's a preferential pathway present, then sampling indoor air or subslab vapor is generally preferred. Identifying and eliminating potential background sources in indoor air can still be challenging, however. In such cases, it's often beneficial to conduct an initial walkthrough indoor air vapor survey using a handheld PID or GC prior to indoor air vapor sampling. It's also important to collect outdoor air samples during indoor air sampling to try and assess whether indoor air concentrations are being affected by background sources in outdoor air. Lastly, it's important to note that collecting a representative subslab vapor sample can be challenging given the tendency to encounter significant spatiotemporal variability in subslab vapor concentrations, and because subslab vapor can be affected by background sources in indoor air. Bounding the variability often requires multiple sampling events at multiple locations. Hopefully it's clear that the characterization of petroleum vapor intrusion sites can be complicated and fraught with uncertainty. It's important, therefore, to design vapor sampling plans such that they target key project goals and objectives and factor in the criteria you see that are listed on this slide. It's also important to think about the implications of the data you collect before it's collected. The sampling of vapor inside and around buildings is often going to require some level of community engagement. ITRC's PVI guidance contains a great chapter on that topic. It's also important to consider potential application of institutional or engineering controls that can eliminate current and future exposures, given that multiple vapor samples and vapor sampling events may be needed to characterize the exposure pathway. ITRC has developed fact sheets on that topic if you want to learn more. At this stage of the CSM, the key chemicals of concern have likely already been identified. Don't forget, however, about chemicals such as lead scavengers that may be present as the result of former fuel releases, or methane which may be present at levels that represent an acute risk. You'll also want to consider the collection of fixed gases such as oxygen, carbon dioxide, and methane in any subsurface vapor analysis to help firm up the conceptual site model for vapor intrusion and any uncertainties around biodegradation. Additionally, most regulatory agencies will require the use of tracers to assess whether leakage has occurred during sampling. In ITRC's Petroleum Vapor Intrusion Guidance, you can also find information on best practices for sampling groundwater, soil, soil gas, and indoor and outdoor air. Included in this section is key information on leak testing, sample location, sampling containers, and analyses that will vary depending on data quality objectives. After the data have been collected, it's important to review the data, lab reports, and any chain of custody forms to assess data quality. ITRC provides useful information and tips to guide one through the review process and to help one understand if the data that have been collected are representative for risk assessment. Examples of data quality issues include detection limits, false positives, such as believing there's an issue when there is none, which could occur if you had contributions from background sources in indoor air. False negatives, where you come away thinking there's not an issue for PVI, yet there is one, which could occur if you had leakage in a canister during shipment. And lastly, sampling errors, such as those associated with leakage during vapor sampling. At this point, it's also important to consider whether modeling can help firm up the conceptual model for vapor intrusion, estimate site-specific rates of biodegradation, develop site-specific cleanup levels, assess remedy effectiveness, or predict potential future exposures. The latter is something that can easily be achieved using vapor transport models. The model selected for petroleum vapor intrusion risk assessment should account for biodegradation in the vadose zone, which is the most important process affecting the potential for vapor intrusion. There are a number of analytical models available for this purpose, including BioVapor, PVI 2D, and US EPA's PVI screen. Model use and acceptability is going to vary, however, depending on the governing regulatory agency. Some agencies allow models to be used as the sole basis for eliminating the PVI pathway, while others require additional lines of evidence, such as vapor samples, for model validation. In general, modeling will be less important at sites where the conceptual model is fairly well understood and when existing data are representative of future conditions. The last steps in the process are simply to determine whether the conceptual site model is sufficient to either eliminate the pathway or whether additional data are needed. Actual cases of petroleum vapor intrusion are generally rare and limited to ones associated with shallow El Naples sources where there's limited oxygen available between the vapor source and building foundation for aerobic biodegradation to occur. These are usually sites where building occupants are complaining of petroleum odors. Very few sites or buildings will actually require some form of vapor control or site management. This is again because biodegradation will reduce source vapor concentrations over time and limit the extent to which hydrocarbon vapors migrate through the vadose zone to a building foundation. When it comes to vapor control, there are two general options. Remediation, which targets the vapor source and is generally applied more regionally, or mitigation, which targets the building and is generally implemented in a shorter time frame. Although vapor extraction technologies are pictured here, remediation and mitigation can take on several forms. In general, remediation is preferred over mitigation for vapor control at petroleum vapor intrusion sites because it can eliminate the vapor source over time. It's also important to note that active mitigation systems, such as subslab depressurization systems, can often be quite costly for petroleum vapor intrusion applications because they must be equipped with off-gas treatment and must be intrinsically safe to avoid the potential for fire and explosions. Again, ITRC has published some great fact sheets and training materials on the subject if you want to learn more. And that concludes this video. If you're interested in obtaining additional information on PVI, LNAP, or TPH, please visit the following ITRC websites, which contain links to both guidance documents and fact sheets.
The Interstate Technology and Regulatory Council is a nonprofit research program of the Environmental Council of the States. ITRC is a state-led organization composed of over 1,000 members from state agencies, federal government, tribal and international organizations, the private sector, academia, and community stakeholders. Members participate in technical teams which produce guidance, tools, resources, and training materials. If you'd like to be a part of ITRC, please visit the ITRC website at itrcweb.org. You can register for teams and learn more about how you can be an active member. ITRC's usage policy is available on the ITRC website. If you do plan to use ITRC materials, we ask you to review that policy in detail and be sure to credit ITRC. ITRC does not warranty the material nor endorse any specific products.